Here we go. Thanks, Scott. As I go through and talk about a few things today, boy, don't stand right there. If you have any questions, please just stop me as I go, especially if it's something I'm talking about right here. I don't mind getting interrupted for a question. If you're just going to complain, wait until the end. We'll cover all that at once, but questions we can do as we go. Look at this, we got a pointy-headed PhD and we can't figure out how to work the pointer. Scott, I'm gonna this slide of these isn't working. Maybe it's switched off.
You might have to just cue in until we get something.
Okay, it's no problem. Yeah, we could just move to the next slide. Maybe the whole thing's frozen. Maybe that's the problem. Oh, it's going here, but it's not. You come for the information and the entertainment's free.
So I can fix it. Actually, we had to do something to set it up. He's got a finger. Hey guys, does it take to fix a pointer?
This is the one I want.
That ain't working.
I tried.
Right on,
I don't know what the hell.
It took the other Andrew to straighten this out. You can give him a tip when he talks next. Oh, now we're going too fast. Here we go. So before I get into what I really wanted to discuss today, which is the topic of breeding for regionally competitive varieties, I thought it would be helpful to just give everyone kind of an example of what the release process looks like for a wheat variety in our program. So this is a hypothetical. Let's just assume that we just approved new wheat for release at a meeting in January of 2023. That line would have originated sometime in 2014 or 15. It would have been in the process of making the cross, doing the initial inbreeding, and some preliminary selection for about 3 years. We have about 4 years of yield testing in our program before it transitions to the statewide variety trial for a couple of years. And in that second year, we start producing foundation seed, anticipating that there's going to be a release of that variety if nothing else changes. So we produce more seed in those early stages than we ever see go out the door because we want to be ready for the things that get released. After 2 years of variety trial, we've got all the agronomic data statewide, the quality data. We might propose that for release. That meeting happens in January of 2023. That meeting was actually held yesterday. So the summer of 23, what would be happening then is foundation seed production for a distribution in 2024. But what we've also started to do is some preliminary on-farm testing, and we're trying to encourage as many counties to include these new varieties in demonstration plots, trying to encourage agronomists to put these into their off-station wheat variety trials to try to get more exposure to these lines. What we saw before was that county agents would get a list of data. Here are the new varieties that are coming out available for distribution in February of this year. You've got a couple of weeks to decide how much seed you want, but we're looking at numbers. They're all abstract concepts. But what we're trying to do now is have that summer in between the release. So it's now a named variety, but we want to give the opportunity for people to see it and touch it and ask questions about it before they ever have to decide if they want a distribution of that seed in their county during the following year. So then this distribution happens in 2024. So 10 years, that's about as fast as we can go. We're pretty limited in the later years of yield trial testing because those data are only taken, once per growing season, and we need to get as much as we can from North Dakota. So that's fast we can go. But it's really crucial, the things that would be happening in this summer after release that oh Lord, what have I done now? Here we go. That you ask questions about these new varieties and you try to seek these out in demonstration plots and at the Research Extension Center variety trials to learn more about them. So the title today that I chose was Breeding for Regionally Competitive Wheat Varieties in North Dakota. And this was really kind of inspired by a situation I had this summer that a couple of the folks in the audience will remember. We were at Walsh County plots looking at the demonstration strips here. And this is what every wheat breeder wants to see when he rolls up to see his new variety in the demonstration strips, just lodging like a son of a gun. And the first question was, what is the story on that one? And for those of you who don't know, that's North Dakota for this looks like crap. Why did you release this? And then somebody kind of gets a little bit further along and they say, well, who would want this exactly? What's the target audience here? And then as we stood around and kicked the dirt some more, we eventually got down to, we wouldn't sell one seed of this around here. And I thought, well, it's a good thing I've been doing this for a few years because this is starting to sting a little. But the thing about Indy Heron was when it was released, it was never intended for production in the East. Now we include all these varieties in all the trials across the state so that in a lot of ways, people can see what they shouldn't be doing. And it turns out that this variety in particular is pretty well suited to the western part of the state. It's just, it gets way, way, way too much rain in Walsh County. And in a summer like this, it ends up lodging. We've got all kinds of problems. So the same month, same variety, same year, we've got two different views of this line in areas that have received significantly less rain, where this looks a lot more like a modern wheat variety. And in testing, it performed quite well, no problems with lodging, and it doesn't look anything like that nasty looking plot we saw in Park River in the previous slide. So what's the difference? Is it just rainfall? It could be, but I think there's other things going on here too. So I'm not going to get into a lot of the details of, the plant breeding class that you would be taking on campus here when we talk about a genotype by environment interaction, but I want you to understand this term and think about what this means in terms of how you select wheat varieties for your farm and how you interpret data that's coming to us from all across the state. So what this means is that there's variation in the performance of two lines in two different environments. So it does really well in one place, doesn't do well in the other place, essentially. We can think of this as differences between an area of adaptation, right? So a really simplistic way of thinking about this is we grow a lot of spring wheat in North Dakota. They develop spring wheat varieties in many states, one of which is Idaho. They've got some very high yielding spring wheat varieties. Why don't we grow Idaho wheat varieties in North Dakota? Well, they don't have the right disease resistance. They don't do well with humidity. They don't tolerate our soil conditions. They are under irrigated production here. And that's an extreme example, but those same differences can be seen across the climate in North Dakota as well. So there's a lot of different ways you can see this variation across environments between two lines. Sometimes there's no differences at all. They're parallel lines. You can test them in Williston or Langdon and they both perform relatively the same. On the other extreme, you've got these lines that cross over on the bottom here, where one is the high yielder at one site and it completely flips at the other site in the state. So how do we handle that as a breeding program, or how do you handle that if you're trying to decide how to sell seed or how to purchase seed? How do they do that with other crops? We don't just buy one soybean variety for all the northern plains, right? Because it's going to work for everybody's maturity group. So we break that geography down. So here's an example with some numbers. This has got actual testing data from different sites in our program. And you can see these are yield numbers here. And you can see things rise and fall across these locations as you move across the lines. So there's different ways. Here's an eastern rank. All of the eastern locations, see 1, 2, 3, 11, 4, 5. You go over here to the western locations. What was number 1 in the east became number 19 in the west. Faller, which is a pretty stable variety, was number 2 in the east, number 5 in the west. Here's a really gnarly example. The number 3 in the east becomes the number 34 in the west. So what am I supposed to do with those as a wheat breeder? Do I try to find something that is the best variety in any farm in all of North Dakota? Or do we have to break the state up into zones and recognize the differences between the east and the west? And I think it's actually, there's more zones than just east and west here. This is a very simplistic way to look at this. Another thing you can do is you can exploit those differences. You can say, here's the Langdon trial. Faller's a really high yielding variety that's done really well in that area for a long time. Here's a line that did 11 something bushels better. Well, why don't we just find this line and release it and tell them to grow that in the area right around Langdon, and then we can really have a hot ticket variety. That's another strategy that you'll see employed in other crops and, can work for different breeding programs. So what are the differences across the state? Well, we already mentioned moisture. We've seen a figure like this before as you march across the state to the west, and the precipitation drops off to about 10 inches, about half, in the far western tier of the state compared to what we have here in the southern part of the Red River Valley. These are huge differences. But we've also got the importance of maturity going north and south. How long the growing season is, how much photo period some of these lines get during the growing season. The importance of maturity for folks north of Highway 2 might be the difference of whether a wheat variety finishes on its own or it needs a little help from desiccation, which I know nobody does. Planting date varies. A lot of that's dictated by the year. Height and lodging, the difference between, again, what is 40 inches in the Devil's Lake Basin might only be 27 inches tall in Williston. Seeding rate, cultural practices, tillage, crop rotation, these things are all different. If I came to you as a new wheat breeder and said, I've done some thinking and I think in this area you should really abandon your current strategies and focus more on sheep and alfalfa, and I'm going to go in a few weeks to Hettinger and I'm going to tell them they should do more sugar beets and dry edible beans. You think I was an idiot, right? This is the same state we're talking about. We can't switch between one end to the other when it comes to crops and the way that we manage our land. So why is it that we think that we can have one wheat variety that fits from this area all the way up through here, when sometimes there's 100 bushel difference in our trial results from the western part to the eastern part? So here are some examples of how we've broken down into the central, the east, and the west, just trying to minimize the number of zones when we present release data. And this is height. This is just a really simple example of how tall these lines get. A line like Murdoch, which is getting a lot of traction here in the eastern part of the state, 27, 28, 29 inches tall in the central and in the west, but get a little more rain on it. In the eastern portion of the state, it was 33 inches tall. This is a pattern we would expect these lines to be pretty parallel, right? Generally speaking, the western locations are going to get less rain. They should be less tall than the central, than the east. And for the most part, these are pretty parallel lines. Plant height is a pretty genetically controlled thing that's affected by the environmental conditions, but it's fairly predictable. But grain yield goes all over the place, and that's what we're looking at here. This is grain yield as a percentage of the trial mean. So we're just looking at how much better than the average they are. For the east, again, central, and then the west. So it's not just rain, but we've got soil conditions, we've got management practices, we've got all these other things affecting what's going on. Some of these lines are parallel, but in some cases they cross over, and what is okay or even the best in one region drops way down in the others. Here's Andy Heron, the one from the pictures earlier. The eastern average, see where the line dips down here? As in the central and the west, this line is much, much better, and in fact is no different from the mean. You bring it out here to the valley and it drops down in terms of preference. We've got other lines where they're better adapted. ND Froberg is another good example. In the east and in the central, but in the west, that line drops down here. So we've got these crossover interactions. Remember, where we've got good or even better or best in the trial in one area of the state, but not so good in the others. So how do we deal with that? Well, we can say, let's just simply break the state into a manageable number of pieces, east, the central, and the west, and let's divide the data by that, present it at the time of release so that everybody knows what they're getting themselves into, and so that we can make people aware that there are going to be problems with some lines in some areas. Did anybody in this room grow Elgin when it came out? I know somebody did. Why did you stop growing it? Something new came out. I suspect that there are more than a few of you that had problems with this line lodging in the eastern part of the state. These data are a little conservative in their numbers, but Elgin's a line that in a good year can be 40 inches tall. It's still the #1 wheat in the southwestern district of the state, and it's hard to beat. But in the Red River Valley, there's a very, very good chance that it's going to lodge. When that line was released, we weren't breaking the data apart in a way like this that would make that message easy to tell. So it's harder to give people a warning about what could happen if you move these things out of their intended zone of adaptation. And it risks you picking something based on a statewide average that might be uniquely difficult for your farm. So how do we deal with this? Well, what are we trying to do? These are the goals as I see them for the northeastern part of our state. And really not in any particular order. These are all pretty important. High and consistent grain yield, short plant height with good straw strength. Somebody mentioned that it was difficult to thresh. Pre-threshing wheats are very, very important, obviously. We want to get away from all the baggage that comes with Glen and its derivatives in terms of how hard that is to thresh. Bacterial leaf streak resistance, FHB resistance, and good end use quality. Each one of these could be blown into probably 10 or 12 subpoints, but this is in general the list of things we're trying to do. So for what's unique to this part of the state, how do we go about achieving those goals? Well, this picture is a little bit small. Can anybody recognize what's going on here? What is it? The leaves are senescent, they're brown, they're nasty looking. Yield has probably gone straight to the tank. This is bacterial leaf streak. This is a picture from our inoculated nursery of bacterial leaf streak that we are intentionally starting these epidemics on our experimental lines in an extremely controlled fashion, and we're directly selecting for this disease. It's the same kind of approach we've been using for fusarium head blight for a number of years. We have to cause the disease and be able to control it in order to find resistance. So there's kind of a couple of things checked off the list. Anybody who's familiar with our program knows that we do a lot of end-use quality screening from the milling and baking perspective to make sure that those lines are suitable for the end users who are buying spring wheat. So that kind of takes care of that. But how do we select for high grain yield when it's specific to a certain area and there's a risk that it's a moving target depending on where you are in the state? Well, we have as many trials as we can get in as many of these unique geographies. And when we analyze the data, we try not to just lump them all together. So instead of a statewide average, where you literally are averaging Williston by Langdon or Hettinger by Castleton, which gets you a number somewhere in the middle, which is basically useful to no one. These are all being segmented into regions of the state where we're looking, instead of at statewide data, where everything starts to look the same, we can see these magnitude differences in the eastern region. Maybe in the future, it'll be even the northeastern region. So we'll break the data 6 ways instead of 3 ways. We're also putting more emphasis on a lot of locations in these kind of key areas of the state where we're developing lines. So we're selecting new populations, and new experimental lines in our program are coming out of the eastern region, the central region, the western region, so that they're being developed and then tested and then grown and increased and then released in those areas. So we know we have a pretty good idea that they'll perform well in those areas. And this is to say nothing of some of the other unique challenges across the state, like salinity or, acid soils, or things that are extremely unique to some parts and not others. But this is just a general look at how we're going about breaking things up, and what I hope we can do with future releases is to be able to provide you with a data set that's most useful to the area where your production is, so that it's not essentially noisy with factors that basically don't matter to you. And it's a complicated process. This is a figure that I use a lot for a lot of the talks that I give to trade teams when they come, foreign buyers of spring wheat who are interested from a milling perspective. They come to learn about how we develop lines, and they a lot of times in these visits, they go and visit farms and they learn about production. So we're trying to educate that group about the left-hand side of this diagram, the things that are important for a producer. Because they'll find the highest quality wheat variety, and their question will be, why doesn't everybody just grow this? Well, if it was perfect for both on-farm traits and in the mill and in the bake, that would be fine. But a lot of times those are, those trade off with each other. So we have to balance the things that are important for producers: yield, straw strength, plant height, how easy it is to harvest, with all of these quality factors. And there's a lot of them. We have 27 different factors that are in our database related to milling and baking characteristics of wheat. And if we're severely deficient on any of these areas, we get very strong feedback from millers and bakers both about the problems that they're having with spring wheat, and how the premium that they pay for our wheat, they expect certain demands to be met. And there are some of these things that overlap. Grain protein is important to everybody in the equation. You've got to have a test weight that doesn't get you into discount range. You've got to have a sound falling number, and a disease resistance, especially when it comes to things like Fusarium head blight, which can compromise the end use quality, are important to both groups. But the give and take in the breeding program means that when we break the state into different regions, and then we try to make sure that both of our customers are met, both the folks buying the seed, the farmers who grow it, and then the folks who are buying the wheat to make it into bread products, everybody has to be happy. One of the things I wanted to talk about just for a moment while I had you here is this wheat quality index that is in the wheat variety trial, and what do we call this thing? The Variety Trial Results and Selection Guide. I know it had a short name, but this book here, this wheat quality index is incorporated into the information in this guide. And what it is it's a weighted mean, essentially, of all of the quality characteristics that we used to present in that book. There was a time when all 27 of those traits were in there, and it was enough to give anybody a headache. And so what we've done is we've pulled out some of the most critical traits from that end user's perspective, and we've analyzed all the lines over multiple years in multiple locations to give them a rank. This is a relative rank, just purely based on quality. So I realized that the other pages in that book that are the agronomic data are the the most important in a lot of cases to folks making decisions about what variety to grow. All I ask is that you try to stay up as high on that list as you can afford to get when it comes to end use quality, and recognize that these factors are the ones that are the most important, and that of the set we've tested in this year, this is essentially the highest to the either most marginal or lowest quality. This is something that came to us from feedback from people using this guide, and it's data that hopefully is easier to digest and understand. And if you have any questions about it or any of the rest of the data that's in that guide, please get a hold of me. If you have any other questions about how to interpret some of the things that we do, or there are things that you'd like to see that aren't being done. So with that, nobody stopped for any questions along the way, so that must mean we saved them all for the complaints period at the end. Yes.
Bacterial leaf streak will be worse in a no-till situation. Wheat product here. Products built up top from 2 years ago, affect the back. Worse than that, eventually killed.
Yeah, so the question's about leftover wheat residue from 2 years ago in a rotation and the effect on BLS inoculum load. I'm going to default to the next Andrew on that one because he's the BLS expert and can answer that question much better than I can. See what I did there? The only person who asked the question, I told him to ask somebody else. Yeah, Brad.
I do this all the time. Again, NDSU, why is this so difficult?
Why is it difficult to breed straw strength into a variety? That's a really good question. I wish I knew the answer to it. I know that it takes a lot of time. So the most recent, there was a release that I proposed yesterday, which is a little bit shorter, a little bit better straw than some. And it took 5, 6, 7 rounds of selection for the strongest straw things in a population or in amongst the lines to get to that. And it still leaves room for improvement. I think it's probably there's a strong genetic control on straw strength. The programs who have it do a nice job of keeping it. And if you take your eye off the ball for 1 second, I think you're going to lose it. Yeah, man. Yeah, so the question was about basically, is there a way to get a handbook or a guide to making a variety excel that was developed in the program for farmers to use to make management decisions? I think it is possible. I'm not going to say that we're going to give you a recipe and ensure that that's going to work every time, but we're starting some work now. We've done this for about the last 3 years where we've got seeding rate trials for a lot of our new materials that are coming out, because we've noticed there's a lot of differences in yield performance of our materials at different seeding rates. I mean, that's, sounds obvious when you say it out loud, but figuring out where the sweet spot is for those new releases coming out so that seed dealers can relay that information when a distribution happens is kind of the first step toward that we're taking. And that's my starting goal for understanding what population should this be at. As far as other management concerns, we would have several years of data for diseases and other things like that. So we're starting to chip away at it. That's just the first place we started to look was what do we need to see this thing at to make it go? And we're finding some, as you would expect, differences between the new materials. So I don't want to say like, here's your cookie cutter recipe for guaranteed success, but if I can give you an educated guess about in your area, what populations have we seen that would do better? That's my first goal. I think we can get there.